Hi students, we are back with the problems from the chapter sound. So here we are going to discuss some of the past previous year question papers as well as the questions from your competency based question paper. Okay, so let's start. The first question is Rohit playing a flute and another playing a piano emit sound of same pitch and loudness. Name one characteristic that is different for the waves from the two different instruments. Here it is mentioned that the sound have the same pitch as well as loudness. So that sound which is different for instrument sound, the characteristics of sound which is different for sounds produced by two different instruments is the quality which depends upon the waveform. Okay, so because the reason is that the sound produced from different sources will have different waveform. Quality or timbre depends upon the waveform of the sound produced. So the first answer will be quality or timbre. Now the second part, it is hinted that the loudness of the sound from the flute becomes 4 times that of the sound from piano. We have to find the ratio of amplitude of the sound of piano to amplitude of sound from this flute. Okay, we have to compare their ratios. Okay, so we need to understand the basic concept. Loudness of the sound is directly proportional to the square of amplitude. Loudness of a sound is directly proportional to square of amplitude. Okay, we use this basic idea to solve the given question. Okay, so let's look. The first answer was quality or the waveform, quality or timbre. So the second answer is, it is given that the loudness of flute becomes 4 times loudness of piano. We need to compare the amplitude of the sound produced by flute is to amplitude of sound produced by piano. Okay, so we know that since loudness is directly proportional to amplitude, also it is given that the loudness produced by flute is 4 times the loudness produced by piano. Upon bringing the loudness produced by piano to the denominator, we have loudness produced by flute divided by loudness produced by piano is equal to 4:1. We already know that loudness is directly proportional to amplitude square. Okay, so here we can replace the loudness produced by the flute by amplitude square of flute divided by amplitude square of piano is equal to 4:1. So we need to calculate the ratio of amplitude. So taking square root on both sides, we will get amplitude of flute divided by amplitude of piano is equal to square root of 4/1, which is equal to 2/1, which is 2:1. So the ratio of their amplitude is 2:1. We need to understand that loudness is directly proportional to amplitude square of amplitude. Okay, so the answer is 2:1. Next is define pitch of the sound. I hope you might have learned this definition. Okay, and the pitch, and the most important fact is that the pitch of a sound depends upon frequency. Pitch depends upon frequency of the sound. When frequency of the sound increases, the pitch also increases. Okay. Next is loudness. Loudness is directly proportional to the square of amplitude. On increasing the amplitude, the loudness of the sound also increases. While quality or the timbre depends upon the waveform. Okay, these are the factors affecting the 3 characteristics of sound. Pitch depends upon frequency, loudness depends upon amplitude. Not only amplitude, there are many more factors which you can refer to your text, and quality depends upon the waveform of the sound produced. Okay. The next question. Rohan conducted experiments on echo in different media. He observed that the minimum distance of X meters is required for the echo to be heard in oxygen and Y meters in benzene. Compare X and Y. Okay, so before moving on to it, let us discuss the equation for echo. If it is an echo, we can use the formula V is equal to 2D divided by T, because the sound has to travel from the source to the obstacle and back from the source obstacle to the source or the listener for echo to be heard. Okay, so velocity can be determined by using the equation V is equal to 2D by T. Okay, velocity is equal to V is equal to 2D by T. This is the basic equation for solving problems related to echo. If the given question is related to a direct sound, then you can use the formula V is equal to simply D divided by T. If it is an echo, then you have to use the equation V is equal to 2D by T. I hope you might have learned the basic conditions for the formation of echo. Okay, that a probable question which can be asked. The minimum distance from the source and obstacle must be 17 meters in air. Okay, and the intensity of the sound produced must be sufficiently high so that the reflected sound will reach back to the listeners. Okay, and the other is the wavelength of the sound wave must be larger compared to the size of the obstacle, so that it can reflect back. Okay, so these are the basic conditions for the formation of echo you need to keep in mind. And if the minimum time period, the persistence of hearing, the minimum time period required is 0.1 seconds, which you have to keep in mind. Okay, for minimum time period required for the formation of echo to be heard distinctly is 0.1 seconds, and the minimum distance must be 17 meters. Okay, so we have to it is given that the speed of sound in oxygen is 340, while that in benzene is 200. We have to compare the distances x and y. Okay, so let's look into it. Given that the speed of sound in oxygen is 340 and speed in benzene is 200 meter per second, the distance traveled in oxygen is x meters for echo to be heard, and in benzene is y meters for the echo to be heard. Okay, in the last slide I have already discussed you that for the minimum time period required for the echo to be heard is 0.1 seconds. Okay, so we can use the equation V is equal to 2d by t. Here we have to calculate the distance. Okay, so d is given by d is equal to V into t by 2. So the distance traveled in oxygen is x. So x is equal to the velocity of the sound in oxygen is 340 into the minimum time required is 0.1 dividing by 2. Upon solving, we get x to be 17 meters. In a similar fashion, we can calculate the value of y. Y is the distance traveled in benzene for echo to be heard. Y is equal to the velocity of the sound in echo is 200. So 200 into, here also the minimum time required for the formation of echo is 0.1 seconds by 2. Upon solving, we will get it as 10 meters. Clearly, we can conclude that x is greater than y. Okay, so the basic conditions or the necessary conditions which you have to keep in mind is, if nothing is said about the distance, the minimum distance required in air for the formation of echo is 17 meters, and the minimum time period required for the echo to be heard distinctly is 0.1 seconds. If nothing is said about the time period, you can use this, and if nothing is said about the distance, you can use this distance too. Okay, and if it is an echo, you can use the formula V is equal to 2d by t. If it is a direct sound, you can use the formula V is equal to d by t. Now, next question. A submarine in air sends an ultrasonic pic and a stopwatch is started simultaneously. The stopwatch, on receiving the reflected waves from an obstacle, and reads 1 minute 40 seconds. Calculate the distance of the obstacle from the submarine. The speed of the sound is given to be 1500 meter per second. So here the time period is given to be 1 minute and 40 seconds. So we need to convert the entire quantity into seconds. So converting, 1 minute is equal to 60 seconds. So 60 plus this 40 gives us 100 seconds. And the velocity is found to be 1500 meter per second. We know that the echo, for formation of echo, V is equal to 2d by t. So we can calculate the distance from using the equation d is equal to V into t by 2. Velocity is 1500 and the time is 100 divided by 2. Okay, on solving, we will get it as 7500 meters, which can also be expressed as 75 kilometers. Okay, simple. The basic equation V is equal to 2d by t. All you need to check is that you have to convert the time which is given in 1 minute and 40 seconds to entirely to seconds, which will be equal to 100 seconds. So next question. A person standing in front of a cliff fires a gun and hears its echo after 3 seconds. So a person standing in front of a cliff fires a gun and he hears the echo after 3 seconds. The speed of the sound in air is found to be 336 meters per second. So we need to calculate the distance of the person from the cliff. After which the person moves a certain distance away from the cliff and then he fires a gun. This time he hears the echo 1.5 seconds later than the first echo. So now we need to calculate the distance which the person has moved away from the cliff. Okay, so it is directly implied in the question that it's an echo. Okay, he hears the first echo after 3 seconds and the velocity of the sound is directly given in the question. Okay, so let's try solving it. This is an apparent figure of the question. Okay, so here this is a cliff and observer is standing at this point, and he from standing at that point he fires a gun, and here's the first echo after 3 seconds, and the velocity is given to be 336. So distance can be calculated. The distance between the cliff and the observer is calculated by using the echo method. D is equal to V into T by 2. On solving, it is found to be 504 meters. So initially the person or the observer was at a distance of 504 meters away from the cliff. Okay, from this scenario he now shifts away from the cliff. Okay, so this was the initial distance between him and the cliff. So now he moves a distance, say x, away from the cliff, so that now the total distance between the person and the initial final position of the person and the cliff is 504 plus x meters. Okay, now standing at this new position, he fires a gun and he hears the echo 1.5 seconds later. So the total time taken for the echo to be heard from the new position is, initially it was 3.5 and now it takes 1.5 seconds more. So the total time for the second echo to be heard is 3 plus 1.5, which is equal to 4.5 seconds. The velocity of the sound remains the same. It will be still 336. So we can equate using the formula D is equal to V into T by 2. We already know that the distance of the person from his final position to the cliff is 504 plus x meters. So 504 plus x is equal to 336 into the new time period taken for the formation of echo is 4.5. So 336 into 4.5 divided by 2. Upon solving, x is found to be 252 meters. So the person has shifted 252 meters away from the cliff from his initial position. Okay, so at this position he hears the echo after 1.5 seconds than the first echo to be heard. Okay. Next question, name the waves used in sonar. Name the waves used in sonar. So for the purpose of sonar, we use ultrasonic sound waves. Okay, ultrasonic waves are used for the sonar. Why do we prefer ultrasonic waves? Because there are 3 reasons. First, they can travel undeviated through a long distance. Okay. Next one is they can be confined to a narrow beam. Moreover, they are not much absorbed in the medium through which it passes, so that it gets the ultrasonic sound waves get reflected back to the medium, thereby enabling us to calculate the distance between the source and the obstacle. Okay, so the waves used by them is ultrasonic sound waves, and the reasons I have already mentioned. Okay, now the next question. The figure shows 2 cliffs A and B, and a person is standing. Okay, the distance between the 2 cliffs is observed to be 170 meters, and the person Leda stands 160 meters away from the nearer cliff. That is, she stands 160 meters from the cliff B. Okay, in the above diagram, Leda stands between 2 cliffs and claps her hands. Determine the time taken by her to hear the first echo. So when she claps, the first echo will be heard by the echo from the nearest cliff. Okay, so it is given that the speed of the sound in air is 320 meters per second. Okay, so let's try to solve it. The first echo heard by Leda will be from the nearest cliff. It is given that the distance between the 2 cliffs is 170 meters and the distance between Leda and the cliff B is 160 meters. So it is obviously evident that the distance between Leda and the cliff A will be 170 minus 60, which will be equal to 10 meters. Okay, so the distance between Leda and the nearest cliff will be D will be equal to 10 meters. Okay, 10 meters. Given that the velocity or the speed of the sound V is equal to 320. So the time taken is, we know that V is equal to 2D by T. Upon solving, T is equal to 2D by V. Okay, substituting the values, we can get the value of time at which Leda hears the first echo. Okay, so the concept is that the first echo heard by Leda will be the echo which is formed from the nearest cliff. Okay, since she is near to the cliff A and the distance between the 2 cliffs is 170 meters and she is 160 meters away from the cliff B, we can conclude that distance between Leda and the cliff A is 10 meters. So on using, it is also mentioned in the question about the speed of sound in air. So using the basic concept or the equation B is equal to 2D by T, we can calculate the time at which he hears the first echo. Okay. So now a question from the topic resonance, the demonstration of resonance. In the given diagram, a vibrating tuning fork is kept near the mouth of a burette filled with water. The length of the air column is adjusted by opening the tap of the burette. At a length of 5 meters of the air column, a loud sound is heard. Okay, name the phenomenon illustrated by the above experiment. So here the phenomenon is nothing but resonance. Okay, I shall explain this concept here. On opening the burette, the level of water column in the burette decreases. Okay, and this place will be occupied by the air particles. Okay, so there the frequency of vibration at this particular length of the air column, that is 5 centimeter, the frequency of vibration of air column matches to the natural frequency of the vibrating tuning fork. So there occurs resonance, that is the matching of frequencies between the vibrating air column and the tuning fork result in the process of resonance. Okay, that means at that particular length of the vibrating air column, the natural frequency of vibration of tuning fork becomes exactly equal to the frequency of the vibrating air column. So when both the frequencies coincide, acoustic resonance take place, and hence a loud sound is heard. Okay, the next question is, why is a loud sound heard at this particular length? A loud sound is heard because the vibrating air column comes in resonance with the tuning fork. Okay, so that is when acoustic resonance take place, the amplitude of the vibrating body decreases rapidly, as a result of which a loud sound is produced. Okay, the first answer is the phenomenon illustrated is resonance, and the second reason is when acoustic resonance take place, a loud sound is heard. Okay, because the frequencies of both the vibrating bodies matches, as a result amplitude increases rapidly, due to which a loud sound can be heard. Now the question is asked, if the present tuning fork is replaced by a tuning fork of higher frequency, should the length of the air column be increased or decreased to produce a louder sound? Okay, so if we replace this tuning fork by a tuning fork of frequency greater than this, naturally the frequency of the vibration of the air column must increase. We already know that the frequency of the vibrating air column is inversely proportional to its length. Okay, so to produce a frequency, to produce a note of higher frequency, we will have to decrease the length of air column. Okay, so if we replace the tuning fork by a tuning fork of higher frequency, for resonance to take place, the frequency of the new tuning fork must match to the natural frequency of the vibrating air column. Okay, we know that the frequency is inversely proportional to the length of vibrating air column. So to produce a sound of louder or higher frequency, we will naturally have to decrease the length of air column, because frequency of the sound is inversely proportional to length of the vibrating air column. So naturally we have to decrease the length of air column from 5 centimeter to a lower value. Now next question, two wires AB and CD of same length, given that the length of both the wires are the same and they are stretched by the same amount. Stretched by the same amount means the tensional force acting on both the strings are the same, which will produce a sound of greater pitch on plucking. Okay, which will produce a greater pitch on plucking. We know that the pitch of a sound depends upon the frequency. Okay, pitch of a sound depends upon frequency, and we know that the factors affecting frequency of a stretched string is frequency is inversely proportional to the length of the string, frequency is inversely proportional to the area of cross section, and frequency is directly proportional to square root of tension. Here we don't have to consider anything about the tension as well as the length, because both are having the same length and both are stretched by the same amount, which means that the tensional force acting on both of the string are the same. So the only factor which we have to consider is about the area of cross section. Okay, we know that frequency of a stretched string is inversely proportional to the cross sectional area. That means when the area of cross section increases, the frequency decreases, and vice versa. Here the area is less and here the area is more. So here the wire AB will have a frequency which is higher compared to the wire of CD. Okay, so the frequency of vibration of the wire AB will be greater and the frequency of vibration of the wire CD will be lesser. Since we know that the frequency of a vibrating or stretched string depends upon, the pitch of which depends upon frequency, we now can conclude that since the frequency of the wire AB is more, it will produce a note of higher frequency or higher pitch. Since pitch depends upon frequency, the frequency of the wire AB is more, so it will produce a sound of higher pitch on plucking. Okay. Next question. The displacement time graph of a sound wave produced by a vibrating wire is shown. How will you adjust the tension in the wire to reduce the length of PR? So basically the PR means the length of one complete wave, which is a wave which is nothing but the wavelength lambda. We are already familiar with the equation V is equal to F lambda, where V is the wave velocity, F is the frequency, and lambda is the wavelength. Okay. So what do we do? How do we adjust the tension to reduce the length of PR? To reduce the length of PR means we have to reduce the length of reduce the wavelength. Okay, we already know the equation V is equal to F lambda. So V is equal to F lambda, from which we can conclude that lambda is equal to V divided by F. Okay, V divided by F. From this we can conclude that the lambda, wavelength and frequency are inversely related. Okay, we can conclude that the wavelength and frequency are inversely related. Lambda is inversely proportional to frequency. Okay, so when lambda increases, frequency decreases, and when frequency decreases, lambda increases. So here we have to decrease the length of PR. That means we have to reduce the wavelength. So in order to reduce the wavelength, what do we have to do? We have to increase the frequency. Okay, we already know that frequency is directly proportional to square root of tension. Frequency varies directly with tension. So to decrease the length of PR means to decrease the wavelength. So to decrease the wavelength, it is just sufficient to increase the frequency. To increase the frequency, we will naturally have to increase the tension on the string. So finally, to conclude that to reduce the length of PR, we will have to increase the tension in the wire. Okay. Which characteristics of sound is affected by the reduction length of PR? We have discussed that since if we reduce the length of PR, the wavelength decreases but the frequency increases. Since the pitch of the sound depends upon the frequency, on decreasing the length of PR, the pitch of the sound goes on increasing. Okay, so the characteristics of sound that is affected by the reduction in the size of or the length of PR is the frequency. Okay, frequency, and frequency in turn depends the pitch. So the final answer is the characteristics of sound which is affected by reduction of length of PR is nothing but it is pitch. So in this figure, we are given the diagrams of 4 symbol pendulums X, Y, Z and W. We have to arrange the following pendulums according to the natural frequency using the equation less than, greater than or equal to. Okay. So one thing you have to understand is that what is the equation relating the frequency of a symbol pendulum? We know that the natural frequency of a symbol pendulum depends only on its length as well as acceleration due to gravity. It is independent of the mass of the bob attached to the symbol pendulum. It is independent of the mass attached to the symbol pendulum. The natural frequency of a vibrating symbol pendulum depends only on its length as well as acceleration due to gravity. Okay, here it is understood that they all have the same length. Okay, they all have the same length. So all of the natural frequencies of X, Y, Z and W will be the same. Okay, so we can conclude that X is equal to Y is equal to Z is equal to W. Okay, with a close reference to this diagram, we can understand that the length of the symbol pendulum is the same, but the mass of the bob is different. We already know that the natural frequency of a symbol pendulum is independent of the mass of the bob, so nothing will happen to their natural frequencies. All of them will have the same natural frequency. Now if the pendulum Z is initiated into oscillation, which pendulum among the other will exhibit the highest amplitude? Since all of them has the natural frequencies and their results in an equal amplitude among all the given pendulums. Okay, so the amplitude of all of the will be the same. Amplitude of vibration of all of these pendulum will be the same. Okay. Give reason for your answer. The reason is that the natural frequency of a simple pendulum is independent upon the mass of the bob. It depends only on length as well as acceleration due to gravity. On a close reference to the diagram, we can conclude that the length of all the pendulums are the same. Moreover, the acceleration due to gravity is same for all these bob, so they will have the same natural frequency for vibration, as a result of which they will have the same amplitude during the vibration when they are set into vibration. Okay. So here, John is trying to create a musical note using water-filled bottles as shown in the picture. So which one of them is most likely to produce a musical note with higher pitch? Okay. We know that pitch of the sound depends upon the frequency of the vibrating air column. Okay. Frequency depends upon the length of air column. We know that frequency is inversely proportional to the length of air column. That is, when the length of air column is less, then the frequency will be more. If the frequency is more, then the pitch will be more. It is clearly evident from the diagram that the length of air column in the bottle B is the least. Okay, so the frequency is more. We know that frequency is inversely proportional to length. So in this diagram, the P has minimum length of air column in it. So the frequency of the sound wave produced from the bottle B will be the maximum. Since the pitch of a sound depends upon the frequency, this B is more likely to produce a sound of higher pitch. Okay, so it is to be noted that frequency is inversely proportional to length, as well as the pitch of a sound depends on frequency. Okay. Next question. A change in amplitude of the sound wave is noticed. Which characteristics of sound is affected due to the above change? We have already discussed that loudness is directly proportional to amplitude square. Okay. So on changing the amplitude, the loudness of the sound will be affected, since loudness is the characteristic of sound which depends on amplitude. Okay. Now next question. How is the amplitude related to your answer? To part A? We have already discussed that loudness is directly proportional to amplitude square. Now what happens to the quality of the sound? We have already discussed that quality or the timbre depends only on the waveform. So since the loudness does not affect the waveform, the quality, nothing will happen to the quality of the sound, and it will remain the same itself. Okay. Now a diagram showing three different patterns of wave produced PQR as shown. We have to compare the wavelength of PQ and R. So we know the relation V is equal to F lambda, where V is called as a wave velocity, F is a frequency, and lambda is a wavelength. So we can write an equation for lambda. Lambda is equal to V by F, from which we can conclude that the wavelength and frequency are inversely related. Okay, wavelength lambda is inversely proportional to this frequency. Okay, so the ratio of wavelength will be the inverse ratio of the frequencies. Okay, so here clearly it is evident that the first wave make a frequency of 3. That is, the frequency produced by the wave P is equal to 3, because there are 3 complete waves produced, and the frequency of the wave produced by Q is equal to 2, and the frequency produced by R is equal to 1. Okay, so in order to find the ratio of wavelength, lambda P is to lambda Q is to lambda R, we just have to take the reciprocal of this quantity. Okay, we know that V is equal to F lambda, and lambda is inversely proportional to F. So ratio frequency of P is to Q is to R is 3 is to 2 is to 1. So in order to calculate the wavelength, we just have to take the reciprocal of it. That is, the reciprocal of 3 is 1 by 3 is to the reciprocal of 2 is 1 by 2 is to the reciprocal of 1 is 1. Upon simplifying, we will have to take the LCM. LCM of 3 and 2 is 6. We have to multiply each of the ratios with 6. That is 1 by 3 into 6 is to 1 by 2 into 6 is to 1 is to 1 into 6. So this on cancelling will get 2. This on cancelling will get 3. And this on simplifying we will get 6. So the ratio of the wavelength will be 2 is to 3 is to 6. This will be the answer. Okay, I hope all the problems discussed in the above video is clear. If you have any doubt in any questions, do comment, and if you like this video, please like, share and subscribe. Comment down what you require for the next class. Thank you.